This here is an overview of the circuit we will be building today. This audio boosting circuit has two separate parts to it. One is a voltage divider, and second is our actual operational amp, which will be boosting our audio in. The first section I would like to talk about is our voltage divider. The reason this is necessary is because we are using a 9-volt AC to DC converter or a 9-volt battery. Either way, it only has a negative and a positive input. The way a voltage divider works is from Ohm's law. Any series circuit, the voltage across from either end is divided in half over the voltage measured inside if they're both equivalent. So we have a 1 kilo ohm resistor and another kilo ohm resistor. To either end we are applying a negative 9 volts, and on this side it's the positive. If we measure from the middle, which is going to be used as our ground, from here to here we get a negative 9 or a negative 4.5 volts. From here to here we get the positive 4.5 volts. This is important because our operational amp requires a negative voltage input, a positive voltage input, and a ground. If you notice, here we have two capacitors. These capacitors are also in series, but they're in parallel with our resistors. The purpose of doing this is to make sure that our voltage is level, so that it does not affect our operational amp. Now I'd like to talk about the second part of our circuit. The second part of this circuit is our operational amp. The operational amp is going to be what is boosting our audio input. This wire here is our audio input. It comes in and goes through this resistor here, which is our 4.7 kilo ohm resistor. This is our potentiometer, and all that is a variable resistor. This is equivalent to 0 to 50 kilo ohms. These two resistors here are the 1.2 kilo ohm resistors on the B side of our operational amp. These connect to the A side of our operational amp. These two resistors are simply going through our ground, again, to enhance the performance and any voltage spikes that we may receive in our unit. This wire here is the audio out of our unit. This is a diagram of our circuit. Here we have the R4, which is the 4.7 kilo ohm resistor, and this is the RF, our 50 kilo ohm potentiometer. The potentiometer is a variable resistor from 0 to 50K. These go into our A section of the amp. It then comes out and goes into the B section of our amp. These two are the 1.2 kilo ohm resistors, and this is our voltage out or audio out. Here we are looking at the formula for an inverting operational amp. That formula is that the V out max is equal to the potentiometer over the R4 resistor times negative and your voltage in, which is also variable depending on your audio source. What we end up with is our V out will be approximately equal to a negative 10.64 times the voltage we put into it at max. Here we have what our minimum is. The minimum is the RF, which can go down to 0, divided by R4. Whenever you have 0 divided by anything, you end up with a 0 out. So now we can control what we have, what we put into the circuit, from 0 to a maximum of negative 10.64 times what we put into it. Now, if you remember what I said earlier, we have two operational amps. And the reason that this is important is because we have a positive voltage in coming from our audio, and we are converting it with the first equation to a negative voltage. We need to convert that back to a positive voltage. So by using the same formula, because these two resistors are equal, they will be equivalent to 1. And this negative and this negative will cancel out, giving us a maximum voltage amplification of 10.64 volts.
The parts needed for this circuit is one breadboard, one 50 kilo ohm potentiometer, two 1000 microfarad capacitors, one 2-wire audio input, one 2-wire audio output, jumper wires, solid core, one 9-volt 2-wire source. You'll need two 1.2 kilo ohm resistors. The banding codes are brown, red, red. Four 1 kilo ohm resistors. The banding codes on those are brown, black, red. One 4.7 kilo ohm resistor. The banding codes are yellow, purple, red. One MC 1458L operational amp. And one speaker. First, we would like to talk about the breadboard. Circuit test solderless breadboards allow you to easily assemble and test circuits without the use of solder, providing you with a quick and reliable method of prototyping. Electrical connections are made by inserting your component leads through the holes into spring clips mounted on metal strips within the board. These strips provide a common electrical connection so additional components can easily be added. Breadboard rows and columns are numbered and lettered to assist in component placement. This is the MB104 board. It contains two separate boards mounted side by side. Each board has a left and a right side that are not connected to each other. Each side has two separate vertical columns for power distribution. Each red column, noted by a plus, is connected in line, and each blue column, noted by a negative, is connected in line, but they are not connected to each other. The numbered horizontal pins, labeled A, B, C, D, E, are all connected in line according to the row number. The numbered horizontal pins, labeled F, G, H, I, J, are all connected in line according to the row number also. Okay. First, we would like to start by showing you the operational amp that we are using. If you notice at the top middle, there is a notch. This allows you to identify where the number 1 pin starts on the left-hand top side. The number 1 pin is the out for the A side of the operational amp. The number 2 pin is the input negative. The number 3 is the input positive for the A. And number 4 is the VCC negative, or voltage negative in. The number 8 pin on the top right is the VCC positive. The number 7 pin is the B amp out. The number 6 is the negative in for the B side. And the number 5 is the positive in for the B side. This 1 amp contains 2 separate amps that can be utilized together. The first thing we are going to do in our example will be to place the operational amp onto the circuit board. With the notch facing towards us, the number 1 pin will go into the row 40 number F, and the 8 pin will go into 40E. We do this to ensure the left and right side of the operational amp are separated. Starting with pin 8, which is the VCC positive in 40E, we will use a small yellow jumper wire to go from 40A to the left red column. That will be your positive input. Then, with pin number 4, which is the VCC negative input, we will take a small yellow wire from 37J to the blue negative column on the far right. We will next need a small orange wire to go from 34E on the left to jump across to 34F on the right. Now we will need to take 2 of the 4 1 kilo ohm resistors. One side of one of the resistors is going to connect to 34D. The other side will connect to 37D, which is in line with pin number 5. The second 1 kilo ohm resistor will plug one side into 34G next to the orange jumper wire. The other end will plug into 38G, which is in line with pin number 3 of the op amp. We will then need to use the white jumper wire to go from 34H to the red positive column of the right side of the board, like so. This will be the connection for our ground. Now we will need the two 1.2 kilo ohm resistors. The first resistor will go from 38D, which is in line with pin 6 of the op amp, and will cross to the other side to 40G, which is in line with pin number 1. The second resistor will go from 38C, which is in line with pin number 6, and go to the other side with 39A, which is in line with pin number 7. Next, we will take the 4.7 kilo ohm resistor. One side of it will go into 39I, which is in line to pin number 2 of the operational amp. The other side will go into pin 45H. Although we are only using this for a mono amplification, we are using a stereo potentiometer. This has 2 sets of pins, but we will only be using one. With the knob facing to the left, we will insert into the board like such. Both sides of the pins are going across either side of the breadboard, making sure that they are not connecting to each other. We will now take a long red jumper wire and plug it from 39J, which is in line from pin number 2, to 59J, which is in line with the first pin of the potentiometer. Next, we will take a long orange jumper and go from 40H, which is in line with pin number 1, to 61J, which is in the middle pin of the potentiometer. This wire will more than likely have to be bent to fit into place. Now we are going to use a stereo output plug that is a female connection. Since we are using mono, we will not need to use the white wire. The red wire will go to pin 39B in line with pin 7 of the op amp. Next, we will take the black wire and plug it to the other side of the breadboard, anywhere into the red column. This is our ground column. Now we are going to connect our stereo input. Again, although we are only using mono, we will not need to use the white wire. The red wire will plug into 45I, which is in line with the 4.7 kilo ohm resistor. The black wire will again go to the ground, red column on the other board. Next, we will be creating a voltage splitter. To make this, we will use two 1000 microfarad capacitors. It is very important to note the polarity of these capacitors. The long leg represents your positive input. The short leg, which also corresponds with the white stripe on the side, represents your negative input. Plugging them in correctly will result in an explosion. Now we will create the voltage splitter. The first capacitor, which is the negative side, will plug into the 15I, and the positive side into 10I. The second capacitor will plug the negative side into 20G, and the positive side into 15G. Next, we will need to use two 1 kilo ohm resistors. The first one will plug one side of into 15J and the other side into 10J. The second one will go into 20F, and the other side will plug into 15F. Now we will use a brown jumper wire, and we will plug it into 10F, and then over to 1C. Next, we will use a long red wire from 20J to the other side of the board, the blue column, which is our negative power supply. We will then use another long red wire from 15H to the red column that we are using as ground. When you plug into these columns, you can plug them into any connection. Next, we will need a long orange wire. We are going to plug it into 1E, then to the red column, which is our positive power supply. Now we are going to be using the power supply. Make sure that the power supply is not plugged into the wall outlet. Now we are going to plug the black wire with the white stripe, which is the positive plug, into 10H. Now we are going to plug the solid black wire, which is the negative, into 20H. Before you plug the power supply into the wall outlet, make sure the capacitors on the top are pointed away from you. If they are hooked up incorrectly, they will explode. Now we are going to test our op-amp. First, we are going to take the speaker plug and plug it into the output. Now we are going to plug the input into some audio device. Now you should be able to use the potentiometer to control the volume. Nothing like Percy Sledge.
True.